So that's on now. Okay, so Ahmad, leave me alone, please. Right. So we're going to be looking at surds now. Maybe next lesson we can talk about complex numbers, and we finished with topic 7, and then we jump to topic 8. Yeah. Hopefully we would have finished all the learning by the end of next week, and then we can start to revise back from topic 1 and have a look at all the things we learned. Topic 1, topic 2, and catch up on the assessments and marking and all of those other things, because everything is behind. It's all closing in on us. We have to do them and get them out of the way. So an irrational number, to start with surds, we have to know what irrational numbers are. An irrational number is a number that cannot be written as an exact fraction, okay? So try to put square root of 2 in your calculator and see what type of number is going to give you.
The same number?
Press the SD button. And if you press the SD button, you'll see that it keeps on going. Yeah. Normally with numbers or with fractions, when you convert them to decimals, they either terminate or they recur. Yeah. Irrational numbers, a lot of them don't do that. Like if you put pi, it will go 3.14 and it will keep on going and changing the numbers forever. It never settles down. Yeah, so that's an irrational number. Basically, if a number is not a square number, then its square root is irrational. Yeah, if you have a number that is not a square number, then if you take the square root, that square root is going to be an irrational number. Okay, so surds are about irrational numbers. Okay, so there's no pattern. They do not terminate. They do not recur. If I try to do 1/9, put that into your calculator and tell me what the answer is.
1/9.
Yeah, put it into your calculator, 1/9. And press the SD button.
0.1.
0.1111.
0.1111 forever. Yeah. So yes, that one is recurring. Yeah, it's recurring. It's a recurring decimal. If you put 1/10, what's that one equal to?
0.1, but not with 1.
It's not recurring, just 0.1. Yeah. So yes, this one is terminating. It's not recurring, it's terminating. It's a terminating decimal. It's 0.1, yeah, on the dot. But this one is tending towards, it's going 0.1, 0.01, 0.1 forever. It's not stopping. And then you have some of them that are like cycles. So have a look at 1/7.
0.142857. It's not the same.
142857, yeah. And if you did this using division, you will see that this is continuing. This, when it gets to 7, it will start from 142857 again. 142857 is, there's a cycle there, yeah. So it's recurring, but it's got a pattern of numbers that are recurring. Yeah, it's going into a cycle. Yeah, if you did 2/7, you have the same numbers cycling again. Yeah, but starting from a different point. If you did 3/7, you would have the same numbers. Try 2/7, and what do you get?
0.28571.
0.28571. You'll find the dot and the dot. Where's the 4? Read it again for me, please.
2857142857.
85714. You can see that this time it's starting from here. Yeah, it's not starting from 1, it's starting from 2857. Try 3/7 and you will see
0.428571.
28571. Yeah, so you see that it's the same numbers on the sevens, but they are cycling, starting from different points each time. Yeah, so that is still recurring. That is still recurring decimal. Yeah, they are still recurring. But some of them don't behave like that. Some of them just don't fall into any, they don't stop, they don't recur, they don't terminate, they don't recur. So we call them irrational numbers. Yeah, and the ones that are the culprits for irrational numbers, good examples, are the square roots of non-square numbers, or the popular one that everybody knows, pi. Okay, pi is an irrational number. Okay, let's see what's on my next slide. I hope you're taking notes. Okay, surds are types of irrational numbers. The square root of n is a surd if n is not a square number. So we're talking about irrational numbers, but surds particularly are types of irrational numbers. And the square root of any number that is not a square number is a surd. Yeah, so the square root of 2 is a surd. The square root of 3 is a surd. The square root of 4, would that be a surd? Will this one be a surd?
I no.
Why is it not a surd?
It will be 2.
Because 4 is exactly, okay? Because we know the answer for that one. Because
Yes.
we know that the square root of 4 is 2. So it can't be an irrational number, yeah? It cannot be an irrational number. So the square root of 2, the square root of 3, these are irrational numbers. These are surds, yeah? Surds are talking about roots now. All of those numbers are irrational, including some other numbers like pi is irrational. But once there's a square root that is not a square number, square root of 5, square root of 7, then they are surds. They are called surds, yeah? Okay. Now, you need to know how to simplify surds. You need to know how to simplify surds. It's on this page, yeah. Now, there are 2 rules. You have the multiplication rule and the division rule. So you need to write those 2 rules down for me in your books. These 2 rules. The first one is the multiplication rule. And the second one is the division rule. And some of you would have done this already in school. Yes, we are recording, Hamad. Thank you. Okay. So what that means basically is if you have the square root of 2 times 3, for example, that would be equal to the square root of 2 times the square root of 3. Yeah, and the same thing goes for the other one. If you have the square root of 2 divided by 3, that will be equal to the square root of 2 over the square root of 3. Yeah, you can write them as individual surds. Okay, let's go to the next slide. Sorry. What have I done? Yeah. Okay, to be able to simplify surds is to be able to write it in the form A root B, okay? Okay, to be able to simplify a surd, it means you should be able to write it in the form A root B. Yeah, so if you have the square root of 12, then you can write the square root of 12 as the square root of, if you have the square root of 12 and they say to simplify it, you can write it as the square root of 4 times 3. And notice here that I carefully chose 4 times 3. I know that I could have done 12 times 1. I could have done 6 times 2, but I carefully chose 4 times 3 because I know that I can simplify 4. Yeah, I know the square root of 4 is 2. I'm looking to include in that, in here, a root that can be simplified. Yeah, so I've chosen 4 times 3. Now I can rewrite 4 times 3, square root of 4 times 3 as the square root of 4 times the square root of 3. Yeah, and this is equal to 2 roots 3. Yeah. 4 is a square number. Yeah, and I know that if it's a square number, then I can write the square root of 4 as a whole number. Yeah, so then I can write it as 2 root 3. Now it's done. Yeah, so that's my example. That's my example. Make sure that you write it down. Yeah, and we can have a look at some ourselves. When does your first lesson finish? 10:30, yeah?
Yes. 10:30, then we have a break, 15 minutes.
Okay, so here's another example. Yeah, it says to simplify the square root of 45. Yeah, and now you know that to write it, to simplify it means you can write it in the form A root B. Now you're going to be thinking about the factors of that includes a square number. Okay, I can write 45 as 15 times 3. I can write it as 45 times 1. I can write it as 9 times
5.
square number. So I can use that one to replace my 45. This is equal to the square root of 9 times 5, which is equal to the square root of 9 times the square root of 5, and that's equal to 3 root 5. Okay, so that's how you do it. That's how you do it. Sorry, guys, I don't know what's happening to my internet today. Am I muted? No. Okay. Let's go back to where we were. Okay, so if we have if it says to simplify x squared y, then we can have it as the square root of x squared times y, yeah? And no, the square root of x squared times y can be written as the square root of x squared times the square root of y. And of course, square can cancel x squared. Square root can cancel square, and then we will have that as x root y. Okay, so that's how you do it. Write that one down. Okay. Now also, if you have something that is like this, written like this, you can have, let's say 3 times root 50, and you're being asked to simplify it, yeah? Then you can write it as 3 times, you need to simplify this one inside 3 times the square root of, you think about the factors, the factor pairs of 50, you can have 50 times 1, you can have 25 times 2, you can have 10 times 5. Of all of them, this is the one that has a square number. So let's use that one, 25 times 2, yeah? And we can write that as 3 times the square root of 25 times 2, yeah? This is equal to 3 times 5 times root 2, yeah? This is equal to 15 times root 2, okay? So that's how you do it. That's how you simplify it. Okay. Now here are your questions, okay? Start with the ones on the questions 1 to 5 on the, I'm going to circle them red, okay? My red questions. Start with the red questions. Simplify those ones for me. Mm-hmm. Well done, Hamad. Okay, we'll see. So it's not as so you can do it then, and you are the one crying.
I finished, teacher.
Well done. Okay, let's see. So square root of 75. If we use 25 times 3. Oh gosh. Then that would be equal to 5 root 3. Okay, so well done to you, Hamad. What did you guys use for this one? There's 9 times something on here. Is it 9 times 7?
Square 9
Mm-hmm.
times square 7.
Yeah. So that would be 3 root
3
7.
square 7.
Yeah, well done. And how about this one?
4 times 5.
And
Then
this would be equal to,
2 square 5.
well done. And how about this one then?
This one, 16 times 2. Then 4 square root 2.
2. Well done.
And the
And the
last
last
one, 49 times 2. Then 7 square root 2.
7 root 2. Well done. See? It's not as crazy as we think it is. Okay. Now this time you're going to do it the opposite. Yeah, you're going to write it as a single root. This time you're going to write it as a single root. To be honest with you guys, this is not A-level, like A-level stuff. These are the things like closing the gaps between your secondary learning and your university learning so that you don't get a shocker to your system when you get to uni. Hello, Dad.
Teacher, this one is opposite.
Yeah, so you have to work backwards. So write this one back to what you think it should have been. Yeah, as a single root. This one will be the square root of something at the end. Yeah.
I finished, teacher.
Okay. One more to finish. Who is in Cardiff? Who else is in Cardiff? Apart from who else is in Cardiff for the lesson on Wednesday?
So the people are not in Cardiff. They don't have to come in the lesson, you know?
You have to, you'll be online. You'll watch me teaching in the classroom in Weybridge. I will connect to online and I will explain all the examples on the board for you so that you can catch up on the board. So the camera will be on the board, okay?
Okay.
So those who are in the class will be in the class, but I will be in the class. So there's only one person in Cardiff, to be honest. The rest of you are at home. So why are we going to have this lesson in Cardiff? Why are we going to have this lesson online, this classroom lesson? When I'm going to have only one student? Oh, trouble. I'm mad. That's good. So you should come to school on Wednesday, then come to Weebridge on Wednesday, okay? For your lesson. Mm. So this is the critical time. You guys just need to pay attention now and, just wrap it up nicely because you've been working hard since January. So just wrap it up neatly and nicely. Yeah. So that when you finish, you know that you finished and you did your best, you tried everything you could, and you've passed and you've moved on. Okay. Some people will come for this lesson at 10:30, believe me. So if you haven't done it already, who has finished the first one?
Me,
Naji, what did you get for the first one?
9 square root 9 times 2.
Which is equal to
3.
18.
Yes.
Yeah? Finish it off like this. All right?
Okay.
Okay.
The second one, 25
Yes.
times 7.
Which is equal to
175.
good. And the third one.
Square root 9 times 10. Equal square root 90.
Well done. And number
Number
4.
4, 36 times 3.
Which is
That's equal 108.
well done. And the last one, the easiest one.
4 times 2 equal 8. Square root of 8.
Well done. Excellent. Yeah. Well done. So Hamad, can you speak any Welsh now? Oh gosh. Oh my goodness. It's so sad that you guys came to Wales when everywhere is just quiet. You could have enjoyed all the everything. Okay. So let me see because Okay. I wanted to give you some others to simplify. Hang on a minute. Okay, I'll try my maths, okay? I wanted to give you some others. So stop share screen. You want to have a chance to do one? I'm putting it on my maths now, okay? For those of you who are, I'm going through it on my maths. Okay. Any number that contains a square root sign, yeah? Square root of 12. Yeah, these are all sorts. Leaving the square root sign in is useful for 2 reasons. We don't need calculators when dealing with them. They are much more accurate as you don't have to round off the decimals. Yes. Root 2 is equivalent to a decimal number that goes on forever. It's irrational. I told you this. You could never write down its decimal accurately. Yes, I already told you. At some point, it would have to be rounded off. Root 2 is 1.414213562, blah, 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 to 9 decimal places, yeah? So I've already told you guys about all of this. That's why I like to come back to my maths to see what's written there, yeah? Surds have their own set of rules. You need to learn the rules. When you have the square root of 4 times the square root of 9, that's the square root of what? 4 times 9 is what? 36, which is 6. Surds have their own sets. That's not what you need to learn the rules. Yeah, the square root of 100 is 10 divided by 5, that is 2. Now you guys are wasting our time with your nonsense. So I've already told you this one. If you have a square number being squared, it can cancel out and that will just become 49 on its own. Yeah, squares can cancel square roots. And you've been doing this anyway with me. 49, square root of 49 squared, square can cancel square root and you just have 49. Should we try that? Yes. I honestly feel scared when I'm pressing that button because I'm thinking, what if it's wrong? Just like all of you, okay? So, but you just have to keep on trying it. Okay, if you square something that has just been square rooted, you will have just what you started with. Yeah. Okay. Match the calculations to their answers by clicking on each pair. Okay, so now I'm going to do this as I'm going to write 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to put the other ones A, B, C, D, E, F, H. Okay, so okay, you're quickly choosing the one you know is going to go. So A and 3, square root of, well done, well done. So Hamad, you got the first one. Let's see. Well done. Okay, let me call names now. You've quickly chose the one you know you can do quickly before anybody takes it off you. Participants, where are my participants? Abdurrahman Al-Shamri, your question is, okay, choose any two that you think can work out. Choose one's problem and answer. Al-Shamri, are you there? No, it's absent, not participating in class.
B with 7
B with 7.
and 8 with C.
C with 8.
Well done. So C with
8.
8. Well done, guys. You guys are doing good. Which ones again?
E with 4.
Now me that I wrote them down. E and 4. Okay.
And D with 6, I think.
6. Yep. Square root of 28. And
F with 5.
which one with 5? F.
F.
Well done. We got 2 more to go.
G with 1 and H with 2.
Yep. And that's the last one now. Well done. Well done. Okay. I haven't taught you this yet. But you should be able to do them. So guys, I've taught you these ones. And not the first ones, but these ones, you can do them. Write as a single sword and then simplify, okay? Write as a single sword, if you can.
50, square root of 15, or?
Square root of 15, yeah? Q. Yeah, for question 1, well done. How about question 2 then?
36.
Square root of 36. Can that be simplified any further?
Yes, 6.
6. Let's try 6 then.
Yeah.
Well done to both of you. Teamwork. Okay. This one is just tell me the answer. It doesn't require any calculations.
7.
7.
7.
Yes.
And
So what can we do about the top one?
The last one is 6.
Should we go with that one?
Yes, square root of 6.
Okay. Well done, guys. Well done. We're doing good, okay?
Yes, I think we need a break, early break.
So you guys have started this problem of early break. Oh, goodness me. Okay. Oh. Right. We'll have the early break at you guys will not make me choke up myself. Okay, when are we coming back? 10:45, yeah?
Yes.
10:45. Okay, so I'm in the background, okay? I'm not away. If you guys have a headache and you want to go on your break, I'm here.
Okay, teacher, see you soon.
Okay. So we are back. I hope you guys had a restful break and you're ready for the next section. Okay. It's time to make a start. I'll do the register. $10:45. So Abdullah Loud, are you there? No. Naji.
Yes.
Abdurrahman Alanazi.
Yes, teacher, I'm here.
Ariam.
Yes, I'm here.
Hamad.
Yes.
Rim. Ibrahim Al-Majed. Khaled Alotaibi. Ali Al-Shirani. Abdurrahman Al-Shamri.
Yes, Miss Amir.
Odey. Okay. Odey Bimadi. Khaled Bauji.
Present.
Okay. Okay, so we're just gonna continue with our with our surds. Yeah. I'm just gonna share the screen so that you guys can we can finish that one off and then I can have a look at another one. Rim, did you not get your timetable? Or you forgot?
No, I was sleeping.
Oh, too much enjoyment from all the Ramadan celebration of Eid. Where are you now? Let me find you. It's okay. Now you're here. So join us, all right? Have you done surds before? No.
I think so, but I don't remember.
Right, okay. So maybe you can just watch for the first couple, okay? So guys, you can get on with it. Odey, Naji, Hamad, and Abdurrahman, the rest of you that are in the class, get on with it. And when we finish, we can explain so that Rim can catch up. have a look. Now this one's a little bit tricky. So this is 2 times root 7 times 1 times root 10. Let's see. 2 times 1 is 2 times root 7.
I think 2 root 70.
Yeah, root 7, that's so root 70. So 7 times 10. So that is 2 times root 70. Can we rewrite root 70 in any way? 2 times root 49 times root 2. Yeah, so this would become 2 times 7 times root 2, which is equal to 14 times root 14 root 2. Which of how many answers do we have? Let's see who is more correct. 28 root 10. Okay, let's put that one in and see. I don't know now whether I will be the wrong one. Okay, Q root 10. We'll put that one and see. Oops, it's not that one. Ali Al-Yafe. Why is he coming to my class? Anyways, let me try another one. 2 times root 70. Is it that one? Oh, well done. Oh, right. Maybe if I, let me see. Maybe if I put, but I feel that that is not simplified like completely. Maybe if I put that one in, maybe it would have worked. I don't know. Okay. So well done to you, Najee. You won the day. You won it for this morning. Oh my goodness. Okay, let's have a go at this one then. I just felt that it's not simplified enough because 70 can still be simplified with 70. So, but 70 is not even 49 times 2. What was I thinking? Goodness me. But you guys did not say anything. You let me finish marking the nonsense, writing the nonsense. Right. Maybe I need to go to sleep like Reem. Okay. So the next one, have a go at the next one, guys, quickly. So Naji won the day. Okay, root 28 for one person. And we'll see what the answer is. I'm going to start off by making some chamomile tea. Anybody finished? Okay. Question 3. Okay, question 2. Okay, let me put numbers on them. This is question 2, and this is question 3. Okay, let's have a look. I can write it all out in expanded form. I can write it as 4 times root 7 times 1 times root 7, yeah? And this would be equal to 4 times 1 times root 7 is 7, yeah? Yeah, so that's equal to 28. Should we check? We got different answers here. Let's see who's right. Is it root 28 or 28? I don't know. Let's see. Is it root 28?
It's just 28.
Ah, so make sure that we don't mix that up in the exam so that we don't lose marks. Okay, let's see. Well done. Okay, how about the last one? Let's have a look.
3 root 3.
Confidence. Okay, we'll see. We'll see now.
Same, teacher.
Okay, we'll see now. 18 root 21 over 6 times root 7. I feel that there's a 7 in here, so I'm just going to have that as 18 times root 21 times root 7 times root 3 over 6 times root 7. I'm going to cancel down the root 7s. And this can go into this one 3 times. So the answer is 3 root 7. Well done, guys. 3 root 3, yeah? So the people that were crying the most about this topic are the people that are enjoying it the most.
Teacher, I can't send you in the chat.
Why?
I don't know. I tried many times.
Oh, you have to go out and come back, because you know what? You guys were still on the stream when my internet went off, and I came back in, but you didn't go out and come back. You understand?
Okay.
Yeah.
Now I go out.
Yeah, go out and then come back in, and I'll let you in.
Okay.
Well done, guys. Great job. Even though I haven't even taught you. Well done. Well done, Hamad. Okay. I'm happy that you are happy on this topic. The topic that you cried about before we started. Okay, so let's have a look at, right. Okay, so now you're back in. You should be able to send me your answers now. So it's part 2. Let me see whether I want to teach you these. I don't know whether I want to teach you these yet. Okay, let's do it. So the other thing that you need to know how to do is how to expand surds. Okay, so now you know how to simplify them. You know what root A times root A is equal to A. Okay, that's the thing that you need to know. Because some of you just now, when you had root 7 times root 7, you didn't realize that the answer to that is 7. Yeah? Okay. So now you've got to use what's inside. You've done this in foundation maths. With this example, you got to use everything that is inside of this bracket, the first bracket, to multiply everything that is inside the other brackets. I like to use these arrows to help me. And then you go for the second one. Right, root 3 times root 3 is equal to 3. Negative 2 times root 3 is equal to negative 2 root 3. Negative, I'm doing this wrong, aren't I? Sorry. I'm sorry, guys. So this would become plus 4 root 3, yeah? And then minus 2 root 3, because negative 2 times root 3 will be negative 2 root 3. And negative 2 times 4 is negative 8. Okay. So now, when you are adding, I thought I was supposed to teach you how to do adding and subtracting surds first before we come to do this. I think we should hang on a minute with this expanding brackets and go back to my PowerPoint. Share. I think it's this one. Share. No, let's go back to yeah, adding and subtracting surds. So we finished this activity. So this is the one that I need to teach you first. Yeah, sometimes I like to follow my math, but other times I like to follow my PowerPoint. Slide is better. Okay, so to add and subtract surds, yeah, the surds have to be like, they have to be the same. So and then once they're the same, you just add what's outside. Yeah, they have to contain the same root sign. You can't do that addition if they do not contain the same root sign. Yeah, so here's an example. So write my example down. First of all, write adding and subtracting surds. So then once the root signs, the roots are the same, you just add the whole numbers and then leave the surd as it is. Yeah, leave the surd as it is and add the whole number. So this would be 3 root 2 add 7 root 2 would be equal to 3 add 7 is 10, and we just leave root 2 as it is. Yeah, we don't touch it. It's like when we were doing common denominators. Yeah, we don't touch what's at the bottom. We leave it as it is, and we just add the top numbers. Think of it that way when you're working with surds. Yeah. So write my example down, and then we can have a look at some more. Have a go at this one. Oh, it's showing you already. So that's my example. Just add or subtract what's outside and leave the surds as it is. Yeah, as long as the surds are the same. Yeah, you must have the same surds. If you don't have the same surds, you cannot do the addition or subtraction. So write this example again. So we're finishing at 12:45. Yeah, we still have some time.
Teacher, if it's different, what should I do?
They are different. You can't add them or subtract them. Yeah. They have to be the same. Okay, so this one is slightly different. This one is slightly different. Yeah. So you have 3 root 2, 3 root 8, add root 50. Yeah. So what you want to do is try and simplify them and see whether you can take them to a place where they have the same surds. Yeah, where you can take them to a place where they have the same similar surds. So you can write this one as 3 times root 4 times root 2 for this one, and then add root 25 times root 2. Yeah, now this one would be equal to 3 times 2 times root 2. Add this one will be equal to 5 times root 2. And on this side, you would have 6 root 2, add 5 root 2. Yeah, now you have common surds. Yeah, yes. So now we have common surds. Once the surds are the same, you just add the whole numbers. Okay, so 6 add 5 is 11. And then times it by root 2. Okay, so that's how we do it. That's how we do that one. So write that one down. Okay. Mhm. Now see if you can do this one for me. Okay, guys. Mhm. Yeah. Okay. Okay. Let's see. Anybody else finished? Anybody else finished? Finito? 12 words. That is 15. In good time. Ah. Well done to you, Hamas. Hamad. Oh, I think I've been listening to the news so much. I don't know what I have in my mouth now. Root 2. Well done. Well done to you. So that's the answer, okay? So you had to do 2 root 8 minus 3 root 32. Yeah, and you want to find a way to have the same roots here. So this would be 2 times root 4 times root 2 minus 3 times root 4, root 16 times root 2. Yeah, this would be 2 times 2 times root 2 minus 3 times root 3 times 4 times root 2. And here you would have 4 root 2 minus 12 root 2, which is equal to 4 minus 12 is negative 8 root 2. Okay, guys, that's the answer. I try to solve it so that you see step by step, because when you see all the numbers on the board, it can be scary. But you need to see step by step how the answers came about. And if you've written down everything, let me clear my drawings. Now it's your turn to have a go at the 5 questions, okay? 5 quick questions. 1, 2, 3, 4, and 5. Off you go, guys. Mhm. Hmm. Mm. Mm-hmm. Yeah, you're back in. Yeah. Hmm. Oh, wow. Somebody has answered all of them. Abdul Rahman. Oh, you answered question 1. Okay, that's good. Wow, you did all that typing. That's good. Okay. Number 1 is straightforward. Well done to you. Your answer is correct, Abdul Rahman. Go on to the next one. You can't hear anything. Wow, that must be from your setting because my volume is on. Have a think about it. The roots are already the same. So what did you have to do? Well done. Well done to you, Naji. I saw your chats, Hamad. Ahmad, you're not in the meeting. You need to go out and come back in. Oh, you have so many. Yeah, it says, yeah, I'll try again. It says you're not in the meeting. I've just written something now. This is the first one that has gone through. Before it was saying you are not in the meeting. Okay. I'm not muted, so you should be able to hear me. My internet has been very unstable today. I don't know why, so we have to manage it. And the sun is coming fast. We come out of that area.
Now I can hear your voice.
Oh, it was my internet then. Okay. Oh, so these are the ones we're working on. Let me have a look at the chats. What happened in the chats? Oh, it has cleared everybody's chat. All your answers are gone. I'm so sorry. Okay. I know Abdurrahman Alanzi had done most of them. Okay, so question 1 was pretty much straightforward.
Teacher, I can't send the answer for question.
You have to go out and come back.
Oh,
This was 10 root 2. If you want to send me a chat, you have to go out and come back because I started a new one. And you are still on the old one. You might still be seeing me. Okay. And this one was, okay, I think, yeah. And this one was root 4 times root 3 plus root 3, which is 2 root 3 plus 1 root 3. Yeah, who knew that? Well done to you. Some of you knew it. 3 root 3. Some people wrote 2 root 3. It's 3 root 3, okay? Don't forget that there's 1 there, even though it's not written. Okay, well done. The answers are coming back in. So this one is 3 root 3. And this one is 3 root 2 minus 3 times, what do we do with this one? Root 9 times root 2. So this would be 3 root 2 minus 3 times 3 root 2, which is equal to 3 root 2 minus 9 root 2, negative 6 root 2. Did we get the answer? Let me check. Yeah, well done, Hamad. Okay. So that's the answer for that one. I'm glad I put this topic in because I see lots of you need to know how to do it. 3 root 8 would be 3 times root 2 times root 4 and minus 7 root 57 times root 25 times root 2. So this would be equal to 3 times 2 root 2 minus 7 times 5 root 2. This is equal to 6 root 2 minus 35 root 2. Is that minus 29? Root 2. Let me see what you guys wrote in the chat. Well done. Abdurrahman, well done to you. Okay. And the last one. The last one is 2 times root 27 plus root 75. Yeah. This is 2 times root 3 times root 9 plus root 25 times root 3. This is equal to 2 times 3 times root 3, add 5 times root 3. 6 root 3 plus 5 root 3 is equal to 11 root 3. Is that what we got? Well done. Okay, so those are the answers for the addition. Yeah. Where are all my drawings? So let's have a look at multiplying surds. Yeah. So when multiplying surds, start by simplifying them, then multiply like terms, okay? You start by simplifying them, then you multiply like terms. So write this example down for me. Okay, so here's another example. Yeah, so you have 3 times root 5 all squared. So you can write this out in expanded form. That will be 3 times root 5 times 3 root 5. Okay, and you can just expand everything out. 3 times root 5 times 3 times root 5. Okay, collect all the number terms. 3 times 3 is 9, times root 5 is 5, and that's equal to 45. Yeah, so write down my example.
So if it's square, we did twice number.
Square means a number times by itself. Yeah, so 5 squared means 5 times 5. Yeah.
Okay. Okay, so
Now have a go at these ones for me. Mhm. Mhm. Okay. So this would be equal to root 2 times root 2 times root 4. Yeah. Root 2 times root 2 is 2, so that'll be equal to 2 root. Oh, nope. Root 2 times root 2 is 2, and root 4 is 2, so 2 times 2 would be equal to 4. Did anybody get that right? Let's have a look. 2 root 4. You didn't get to the end of it. Root 4 is not a surd, okay? It's a rational number. Okay, so this would be root 2 times root 3. Yeah, for this one, times root 3. Root 3 times root 3 is equal to 3. So this will be equal to 3 root 2. Let's have a look in the chat. Well done, Abdurrahman. Well done, Hamad. Okay, and this is root 3 times root 4 times root 3. Yeah, root 3 times root 3 is 3. 4 is 2, so that's 6. Okay. Which of you wrote 3 root 4? Let me see. 3 root 4. I didn't get any in the chat. I know that some of you write it. Or 4 root 3. Okay, well done. Right, let's have a look at the harder ones. So root 30. Root 30 is what? 5 times 6. Yeah, so this would be root 5. Oh, come on. Root 5 times root 6 times root 5. Yeah, so these two guys here will go off to become 5 root 6. Okay, how about the last one now? The last one is root 5 times root 3 times root 4 times root 3. So this would be 3. Root 3 times root 3 is 3. Root 4 is 2 times root 5. And that would be 6 root 5. Did anybody get that right? Well done, Abdurrahman. Yeah, well done, Hamad. Okay. Let's keep it going. We still have to do it on my maths. Clear all my drawings. So when you're dividing, it's very similar. So you've done multiplication. Make sure you write the heading as multiplication. Yeah, multiplying surds. And when you're dividing, it's similar. Okay, you have to use your idea of simplifying. But the main thing that you have to know is that you cannot have rational numbers in the bottom number. The denominator, you cannot have irrational numbers in the denominator. Okay, so what do we do to get rid of that root 2 in the bottom number? We know that root 2 times root 2 is equal to 2. So we can times the top number and the bottom number by root 2. Yeah. So if we times this by root 2 and times this by root 2, then we will have 3 root 2 over 2. Yeah. So that's how we do it. That's how we do it. So 3 root 2, yeah, is equal to this, and that's equal to this. Okay. So now it's all clear. We don't have any irrational number on the bottom number, and that's called rationalizing the denominator. So make sure you write that down. Rationalizing the denominator. Because if you put an irrational number in the denominator, it's going to mess up that whole calculation. It's going to change everything to irrational and mess it up. So we don't like to have it in the bottom number. We like to have it, the bottom number, as a nice clear whole number, so that we can know how our fraction is working out. Yeah.
Hey, Gladys.
Yes.
Hello.
Oh,
Hi, everybody. How are we doing?
Fine.
Okay. Okay. Can I just ask Gladys, could you put me in a breakout room with Ariam for a minute, please? I just need to-
Aria. Okay.
Okay. Thank you.
Let's have a look. Breakout rooms. Yes. Aria.
Miss, you invited me. I am Reem.
Please, I'm sorry. All of you should come out of it. Oh my goodness. Oh gosh, all of you should come out. You shouldn't be there. I don't even know what happened. Why is Khaled there? Right. I need to kick him out. Okay. I'm sorry, guys. Okay, let's continue with our lesson. So here you are, guys. You need to rationalize the denominator. Maybe I'll do the first one, but they are very much straightforward, okay? You can easily do them.
Okay. Sorry, Gladys. It was Ariam I needed. I ended up with Abdul Rahman and Khalid.
Breakout room. So that's a problem because I've added her, but she's not responding.
She's not responding. Okay, it can. All right. Can you just put me in then? Oh no, she needs to join it, doesn't she?
Yeah. Let me chat. Let me chat. See whether she's going to respond to a chat.
Brilliant. Thank you.
Ariam. She's not there.
She's not there. Okay, I'll try and contact her then. Could you, if she's not responding, could you just remove her from the class then and mark her absent?
Yeah.
All
Okay.
right, thank you. All right.
Okay. Attending. Ariam. Absent. Okay, right. So let's continue with the lesson then. So it was this one. Yeah, so it's very straightforward. You just have to, like, for that one is 6/√2 times √2 over √2, and you just times the top. You know that when you're multiplying fractions, you multiply the top numbers and you multiply the bottom numbers, yeah? So this would be 6√2 over 2. Now I've done this one for you guys. You can have a go at the rest, okay? Rationalize the denominator. So you just came in a day, so and when you came in, you had to say you were in because I was teaching when you came in. Yeah, so if you want me to mark you in, you have to remind me that you are just coming. Okay, right. Okay, so everybody's in now. All those who are here are in now. Hmm. Okay, so, but you still have to tell me, even if it's 1 minute, yeah? If you know that I have already finished marking the register, if I did not say that, if I did not mention to you, if I did not mention your name, like when Rim came in, I said Rim, I spoke to her. But sometimes when I'm explaining, I will not remember. It's your duty to remind me because you came in late. When I was doing the register, you were not there. You understand? So it's not my responsibility to remember to mark you in. Yeah. In breakout room with who? Andre has gone already. You want to go into breakout room with Andre? He has gone already. No, he has gone already. Okay, sorry. You should have told me earlier enough. Oh my goodness. So, guys, if you haven't filled the questionnaire, yeah, the one that was sent out to be filled in by everybody today, then I'm going to share the link and the code. Yeah, what's that code? Who has the code now? I hope I haven't thrown it away. Oh my goodness. Okay, I'm just going to copy it from my email. I think I have it on my email. People's questionnaire. Okay, so the code is okay, I'll put it. No, it's I don't know. You can contact him, you can email him, okay? So let me just share that information that is this one. You can contact him by email or right. And I'll just put it, if you haven't filled this form, you need to go and do it now before the end of the lesson, everybody, okay? I'll just share the link. You need to visit the link and the password is CWAM or capital letters. RWAG. KPS. Okay. Okay, so everyone that came in much later needs to go and complete that form, okay? The rest of them that came in first thing in the morning have already done so. So you need to go and complete it. You need to go and say, you need to put strongly agree and you can say agree or strongly agree, okay? On the, yeah, to tell them how well you are enjoying our school, yeah? How good our school is performing. I think most of you, you know that we have tried our best for you despite the lockdown and everything. So you should get to this form. Let me share that with you. For those of you who haven't been here. Sorry, I'll bring it back. I'll bring up the PowerPoint later. So you need to be on this one, okay? And give some feedback, all right? No, I'll leave that on. I'll leave the YouTube on. Yeah, so maybe yeah, the workload has been overwhelming. That's because you've crammed everything in, but we've mostly tried our best to give you your learning as much as we can. So when you're answering those questions, think about, you know, we have been a good school, so you can always say that you had your foundation program at Weybridge Academy in Cardiff, you know, and you're going to uni in September. So definitely we have done a good job on you. So when you're feeling, make sure you're giving us the good rating or the right rating for us that we deserve. All right. Okay. I'm not good at making these types of speeches. I think when Kat came in the morning, she was really good. So anyways, follow the links, okay? Make sure that you complete it now because it's expiring today. You need to do it, and you need to, the password is the one that I put in second after the first link. All right. So I'm going to go back to my presentation. Oh, it's not this one. Was it this one? Yeah, we were trying to rationalize this one. Okay, so what did we get for this one? This was equal to 6 root 2 over 2. And this would be equal to what? 10 root 5 over 5. Did we get that? Yeah. Okay, and for this one would be 4 over root 8 times root 8 over root 8. This would be 4 root 8 over 8. And I'm happy if you want to simplify this one further. Yeah, you can definitely simplify that one to 8 root 2 over 8. I think so. Because this can come to 4 times 2. Yeah, okay. So that answer will be correct, and this one will be correct as well. Any of them you put in will be correct. Sometimes when I'm doing it wrong, you guys will just be quiet. You let me do it wrong, and when I finish, you let me do it wrong. So this one is what? 4 root 8 over 8, or 8 root 2 over 8, anyone. Yeah, so 21 over root 7 times root 7 over root 7. This is equal to 21 root 7 over 7. Okay. Now here you have other things. You have 2 root 3 over 5 times root 5 over root 5. I'm sorry, root 5. So these guys will become 5. This will become 2 root 15. Can that not be simplified? Yeah, that's okay. 2 times root 15. Yeah. That's the answer to that one. And this one is 3 times root 2 over 10 times over root 10 times root 10 over root 10. This is equal to 10. And we can write this as 3 times root 20, which root 20 can simplify to root 4 times root 5, which is equal to 2 root 5. Yeah, so that will become 6 roots. 2 times 3 root 6, that will become 6 root 5 over 10. Yeah, where can I put that? I don't know. 6 root 5 over 10. Any questions? Okay. Do we want to stop there for today, or do we want to do more?
We want to finish.
You that you came last minute, .com. Oh, goodness me. Okay, so we go back to my maths now, because that's where we were trying to do expanding brackets before I brought you back to my PowerPoint. So let's go back to my maths. I'm going to put it back on first. What's this one? This one. Yeah, okay. Okay, so we do it in the same way as we do expanding brackets in algebra, yeah? So we use what's inside the first bracket to multiply everything that is inside the second bracket, yeah? And I will explain all that to you now, so that you don't get it confused. So just write expanding brackets for me. The rest of the class, they are going to say, Rim, you just came and you're just telling us to stay and continue learning till our heads explode. All right. So you're going to use what's inside this bracket to multiply everything that is inside the other bracket. Let's start with the first number and the other two. Root 3 times root 3 is 3. And root 3 times 4 is 4 root 3. And root And negative 2 times root 3 is minus 2 root 3. Negative 2 times 4 is negative 8. Okay, you can see here that they have common surds, so you can definitely do that subtraction. So it will be 3 subtract 4. 3 subtract 4. 3 subtract 8 is negative 5. Yeah, and 4 minus 2 is plus 2 root 3. Yeah, and that would be your answer. So write down the example. I've explained it to you so that you know step by step how to do it. Let me just check my calendar to see when our exam is. That's okay, yeah. So our exam and how many more weeks we have to do any more learning so that we can finish off. And today is the 17th, so we only have this week and next week to do any more learning. And the other week is going to be all revision and preparation for the exam because it's the 10th of, your exam is on the 10th, which is, 10th of June, which is a Wednesday. So really, we need to begin to revise from next week, Wednesday. Really, we just have about 1 week to do any learning. And we need to start to revise from topic 1 and make sure that we finished all our assignments and everything. Yeah. I know. Some people are going to cry. Some people are going to cry. Maybe I will be the one crying. Oh, they are gone. My students are gone. There's nobody to trouble me anymore. Yeah. So I hope all of you can pass the first time so that you don't have to be doing receipts and be stressed out. Okay. Okay, so that's how you expand it. Let's have a look at the other slide. So have a go at this one and let's see whether you can do it. You have 5 times 5 is 25. 5 times root 2 is plus 5 root 2. Negative 2 times 5 is minus 2 minus 5 root 2. And root 2 times root 2 is minus 2, yeah? Let's check. I knew they were trying to show you something else. That's why I said, let me explain it first. Because you may not know it. Maybe asking you to do something you can't do. Okay. I've already done that one for you. Okay. How did we get there? Come on, let's go back. Yeah, okay. So right, that's where I was going to. Let me take this back up. So these guys will cancel out each other because this is minus, this is plus, and this is minus, and they're the same. Okay, it's like saying minus 5 plus 5 or plus 5 minus 5. Yeah, that will come to 0. And of course, I already told you that this is 2 here. So 25 minus 2 is just going to leave you with 23 as the final answer. Okay, so write that example down. You guys are a good class. Some of my classes, when I'm teaching them, they will be crying. They want to go. It's so hard. Their head is paining them. This and that. It's too much. Well, you guys are a good class, so that's good. You want to learn. Okay. I think I've told you about the difference of two squares before. Yeah, I think we did this when we were looking at quadratic equations. You already know it. Yeah. So you know that the middle ones will cancel out each other. So the most important things are this one, this calculation, and the final calculation, yeah? So all you have to do is 5 squared minus 2, yeah? Well, let's not get into that. Don't worry about it, okay? Don't worry about that, because that's not really important. As long as you know how to do the expansion, I'm happy. Okay, so should I let you guys do all of them? You got how many minutes? 8 minutes. You should. Question 1, 2, 3, 4, 5. It's worth it to try all the different ones because they may all have different challenges in them. Okay? Oh, goodness me. So tired. Okay, any answers? So if you have no answers, then you can finish working on it and we can have a look at the answers tomorrow because we only got 2 minutes left. All right, guys. Well done for your hard work. I'm just going to leave it open on my computer and tomorrow we can continue from where we stopped and we'll finish all the other modules. You see, you have to do more rationalizing the denominator for more complex ones. And there's Surds 3 on here as well. Okay. So be ready. Yeah. Be ready for tomorrow. And after that, we're going to have a look at complex numbers. Okay. I shall see you guys tomorrow, all right? So the lesson is over for today.
Okay, have a good day.
And you.
Thank you.
All right. Bye. Bye.
Bye.
Bye.
Thank you, teacher.
Thank you. Bye.
Bye.
Bye, teacher.
Bye.